So challenge us, folks. Howard especially, I know you can. But don't be afraid to speak up and ask about this stuff, because we want you to really understand this, that the really unique benefits. Some of this messaging is hard. When you're software-defined storage, oh, well, we've heard software-defined storage stories before, so it just sounds like another software-defined storage. We are truly unique in that we are not using any CPU on the target, so you can use all that CPU for your host. Additionally, Yaniv said hundreds of thousands of IOPS, but we're going to show you the demo later that we can very easily get to millions of IOPS. You could get to 100 million IOPS if you wanted in a rack. Now that's not in any of our documentation. It's not on the website, because what do you do with 100 million IOPS? It's kind of a joke, a rhetorical question. I think the answer is whatever you want. The point of that is when you have millions of IOPS available, you're no longer worried about being constrained. You don't have to use them all, but you're no longer constrained. So what can you do with this? In web and cloud, it means that you can achieve your goals of hardware homogeneity. Because whatever you pick to homogenize on, if you use 1U servers or 2 servers in 1U or other dense form factor, you can do an entire rack of this. And you can only put one NVMe drive, or you can put a couple of NVMe drives per. And we can unify that entire pool. And no longer are the applications there subject to only being limited to the NVMe that they have within the host. They can use NVMe anywhere in the rack, and it performs at the same level. It performs just like it is local flash. The same latencies, same bandwidth. So this means that if you had a 1 terabyte card or SSD in your server, when your database hits 950 gigabytes and you start getting really worried about what I'm going to do, the answer is just grow your logical volume and it spreads out amongst the cluster, and you can do whatever you want. There's no more limits there. It also means all data is local. There's no such thing anymore as localization. All data is local. You can achieve the holy grail of moving compute to the data rather than moving compute around your data center. So for web and cloud, this means you can achieve true homogeneity, lay it out however you want. You no longer have to over-provision. You don't get these really low utilization rates. You can use standardized servers, just add our software, and you can do anything you want. So applications in web and cloud are operational analytics, Splunk, Elk Stack, databases, any kind of database, in-memory, SQL, doesn't matter. You can run all these. If you run out of space, you grow the volumes or you create new volumes. If your server crashes, it doesn't matter. You start up the application on an alternate server. You still have that shared data available anywhere in the rack, anywhere in the data center if you want it to be.
Now you mentioned that you're block storage. Does that mean you're iSCSI or Fiber Channel or?
It means we are, Yaniv's going to get into that. I want to let him do that technology piece, but the short answer is we are an installable client that looks like a block device.
It doesn't use any CPU cycles.
The client side uses CPU cycles like any client would. When you use a regular Linux block driver, you're using up some CPU for the kernel to go ahead and process that I/O, but we use very, very little. We use something just approximately the same as an iSCSI client or initiator is language you would be more familiar with. So we do have something equivalent to an initiator, but it has nothing to do with iSCSI. We're not speaking SCSI protocol. We are optimized and designed for NVMe. So real-time analytics, intrusion detection. What happens, when someone's attacking your network? You need to process that stuff as fast as possible, as close to real time. You need ultra-low latency, tons and tons of small little pieces of data. That's the kind of thing we can handle with this, because you can have very large pools. You can split pools over multiple systems. You can get as many IOPS at as little latency and as much capacity as you want. Yaniv mentioned this, so no noisy neighbors. Because we're not using up CPU, you can run applications on the same hosts that are sharing their drives. Someone else taxing your disks on I/O is not going to affect your CPU. So this is why we say you can do true convergence. And you can make it as optimal as possible. In web and cloud, through interviews we've done with some of the biggest properties out there, such as, thank you, Yuval from LinkedIn. When we'd surveyed LinkedIn, they told us, yeah, we're deploying Flash today. We're 15, maybe at a good day, we're 25% capacity utilized overall. Because one server would use 90% of its flash drive, and the other server down below it would only use 10. So overall, they had very, very poor utilization because they had over-provisioned to maximum need. You no longer have to do that. With us, you can get as close to 100% efficiency as you want. If you want to add protection, which they didn't have before, protection against disk failure, in our first version, it's mirroring or striped and mirrored. You can still get to 50%. 50% is still twice as good as 25%. So you can greatly increase efficiency.
I hadn't figured that out.
That's why I'm the marketing guy is talking to you, just to help along with the hard math stuff. Any questions on web and cloud? Innovative enterprise. What do we mean by this? Web and cloud is what we said our target market is. The Fortune 500 traditional enterprise, not our market, at least not right now. But every enterprise, and you guys all know this, every enterprise has a pocket where they have to do something special. And for competitive advantage today, you have to. Walmart has this program you guys may have heard about. They're competing fiercely against this German-owned grocery store and against Kroger, and they're doing this price matching war. How do they do that? They're collecting tons of information about all these prices and doing analytics and doing customer studies on who's buying what. All this has to happen overnight so that they can reprice things the next day. So every enterprise has a low latency, high bandwidth need, and it's only going to get bigger and bigger, the need that is in the market, because of the amount of data coming in. Call it the Internet of Things, call it whatever you want. But data is not going away. We're getting bigger and bigger, and you have to analyze more and more of it. So in this, there's somewhat similar things as in web and cloud, just with a little bit a different take. Real-time analytics, databases, of course. Here we're talking more traditional databases. Container environments, someone's moving over to containers. We have a persistent storage layer that can be used with containers. But when you have a container host die, you can restart your application containers on an alternate server and have all your data performing at local speeds, local latencies.
But on containers, would you actually need that sort of high-end performance? Because the whole point of containerized solutions would be distributed low IOPS kind of applications, like a cluster of web farms or whatever. So do you actually need this level of?
Sure. If you want to containerize, and people have hesitated doing this, by the way, to your point exactly. What if you want to containerize part of your application that uses a MySQL instance? It uses a MySQL database, which can be divided over a bunch, but there is a resident store, a part of that is on disk. Today, you would just put a local flash drive in every single host. And if that flash drive died or the host died, you have to restart the application somewhere else, which means you have to have been replicating your database, which means you probably had to replicate it 3 times.
You probably can't think of the use case because you can't do it today, so no one's going to think about the use case.
Yeah, I suppose.
Yeah, well, it's not what containers were designed to do, but we're starting to see containers as a software distribution method.
Yeah.
So that when MySQL comes out with a new version, they put it in a container, and now they don't have to worry about supporting Red Hat and Debian and Ubuntu and SUSE. And so it's not about that they're ephemeral and they pop up and Kubernetes manages them. It's about it's easy for the software developer to distribute it this way, so we have to support it.
Not only that, if you...
So Howard, I'm sorry, I was told that you were not going to help me, so I'm surprised, but thank you for...
Howard is not the enemy.
You have to... I told you...
Who told you that?
I had to watch out. You know your stuff, but no, he's 100% right. People want to do more things with microservices, but because they don't have a persistent storage platform that can be shared or can survive that server failure or that drive failure, they don't do it. Now you can. And we can integrate, because we have a RESTful interface, we can write layers. We've integrated into automation, orchestration layers like Mesos, like Docker itself, the persistent storage plugin, and we're working on a Kubernetes one. Lastly, and this one should be obvious, high performance computing. And this was made obvious by our first paying customer that was NASA Ames at Moffett Field. And we'll get into that use case later. I'll tell you exactly what they're doing. But what does NVMe offer? Extremely high bandwidth, extremely high IOPS. And it's great. If it's in one server, though, what do you do with it? Well, you want to tap that. You want to aggregate it. You want to use it all as one. Use it for we actually were using it in a local file system amongst multiple servers. It's an interesting way to do it. But you can put a clustered file system, such as Lustre, such as IBM's formerly GPFS, now Spectrum Scale. Spectrum Scale has some very interesting properties that make it a fantastic fit with our device, because our device is available to be multi-attached. So you can attach it to every single GPFS client or NSD, and they see the device as if it's local, which means when it does I/O, it does the I/O to what it thinks is the local device, even though it's actually a shared device. So there's no more proxying through NSDs. So it makes your access very, very low latency. You can build tremendously powerful analytics clusters and things like this. The best thing is no more data locality again. You bring in, for analytics, you bring in your large, high bandwidth job by writing into the data space, and then it just sits there. Then you do your analytics run. There's no more copying. If you actually had your streaming input go right into this same file system, the data's there. There's no more copying. There's no more data movement. So you can do really interesting things on moving compute to the data rather than having to shuffle data around. So HPC is another really big use case.